Objectives. 1. To study charging and discharging characteristics of a capacitor. 2. To find the time constant for the RC circuit. 2. Apparatus. 1. Charge/discharge circuit containing several resistors, a 1.0 farad capacitor, and battery holders. 2. Voltage/current sensor. 3. AA batteries. 4. Connecting wires. 5. Computer interface. 6. Data studio software. 3. Experimental setup. 1. Battery AA. 2. Resistor R. 3. Capacitor C equals 1.0 farads. 4. Charge/open/discharge switch. 5. Voltage/current sensor. 6. Computer interface/data studio. 7. Current direction during charging. 1. Charge 2. Open 3. Discharge 4. Switch positions. 1. Charge 2. Open 3. Discharge 5. Procedure. Summary 1. Connect as shown in the setup. 2. Attach sensors. Connect interface to computer. 3. Move switch to discharge for several seconds, then move to open position. 4. Open the file, capacitor pp.ds. 5. Press start in Data Studio. 6. Move switch to charge until current and voltage remain constant. 7. Move switch to open position. 8. Remove the batteries. 9. Remove the batteries. 10. Move switch to discharge until current and voltage remain constant. 11. Press stop in Data Studio. 6. Key equations and no charging charge. Q equals CV0. Open parenthesis 1 minus e to the power of minus t over RC, close parenthesis charge builds up. Charging voltage, VC equals V0 open parenthesis on minus e to the power of minus t over RC, close parenthesis voltage rises. GV or resistor voltage, VR equals V0 minus VC equals V0e to the power of minus t over RC voltage falls. Current, I equals I0, e to the power of minus t over R, C current decreases. Trarbikak, discharging voltage V, C equals V0, e to the power of minus t over RC. Voltage falls. Time constant tau equals RC. Tau controls the speed. Note as t approaches infinity, VC approaches V0 and I approaches 0. In other words, as the capacitor charges with time, its voltage approaches V0, and the charge on its plates approaches the steady-state condition, which means that I equals 0 and Q equals CV0, 7. What is a capacitor? A capacitor is made of a dielectric material with two parallel plates. A capacitor stores electric charge. 1. Positive charge plus Q. 2. Dielectric material 3. Negative charge minus QC equals Q over V1. C equals capacitance 2. Q equals charge 3. V equals voltage 8. Time constant tau equals RC. The time constant is the amount of time it takes for the charge of the capacitor to equal 63.2% of its final value when charging, or 36.8% of its initial value when discharging. 1, 0, 2, tau, 3, 2, tau, 4, 3 tau, 5, 4 tau. A general rule of thumb, nearly complete charge to V0 or discharge to 0 takes about 4 RC. 9. Charging process. Vertical axis, V sub C of t horizontal axis, time final voltage, V sub 0. At tau equals RC, the capacitor reaches 0.63, 2 volts, 0 equals 63.2%, 63.2% of volts 0 at t equals tau. During charging, the capacitor voltage increases with time and approaches the battery voltage V0. As time becomes very large, VC approaches V0 and I approaches 0. 10. Discharging process. Vertical axis, V sub C of t. Horizontal axis, time initial voltage, V sub 0. At tau equals RC, the capacitor falls to 0. 0.368 volts, 0 equals 36.8%. 36.8% of volts 0 at t equals tau. During discharging, the capacitor loses stored charge, so the voltage decreases with time. Current also decreases with time. Focus 11. How to find tau from data. 1. Fill the charging table. 2. Plot Vc versus T for charging. 3. Find tau from the charging curve. 4. Fill the discharging table. 5. Plot Vc versus T for discharging. 6. Plot natural log of V0 over Vc versus T. 7. Find the slope of the straight line. 8. Use the slope to find tau. 9. Find the average time constant. 10. Compare average tau with tau equals RC. 12. Table 8.1. Charging of the capacitor. 1. V0 equals ... volts. 2. R equals ... ohms. 3. C equals ... farads. 1. VC, volts, C. Ohms. 3. C equals farads. 1. V sub C, volts. 2. T seconds. 1. 0.252, 0.53, 1.04, 1.55, 2.06, 2.57, 2.7513. Table 8.2, discharging of the capacitor. 1. V0 equals ... volts. 2. R equals ... ohms. 3. C equals ... farads. 1. Vc, volts. 2. Natural log of V0 over Vc. 3. T, seconds. 1. 2.752, 2.53, 2.04, 1.55, 1.06, 0.57, 0.2514. Simple meaning. A capacitor does not charge or discharge instantly. It needs time. The value tau equals R,